You know, the funny thing about limits is that nature doesn't usually announce them with a big red sign that says, "Stop here." We expect speed to work like common sense. You push harder, you go faster. You push much harder, you go much faster. That's how bicycles work. That's how cars work. That's how you get late to a meeting and discover new, previously unknown abilities in your right foot. So naturally, you'd expect light to be the same. Shine it harder, whatever that means, and it ought to go faster. But it doesn't. No matter what you do, no matter how clever you are, no matter how much energy you dump in, light just shrugs and keeps going at the same speed. Always, every time. Like it's mocking you. Now here's where things get uncomfortable. Suppose I'm standing still and I shine a flashlight. I measure the speed of that light and I get a very famous number. Fine. No surprise. But now suppose I start running toward the beam. Common sense says I should measure the light going faster, the same way you'd measure a baseball, going faster if you ran toward it. That's how velocities add. That's how they must add. Otherwise, the universe would be completely unreasonable. Except, they don't I still measure the same speed of light. That's not a small problem. That's not a detail you fix later with better instruments. That's a complete demolition of how motion is supposed to work. Because now we're stuck with a paradox. Either everyone in the universe is wrong about how speeds add, or space and time themselves are playing a trick on us. And I'll give you a hint. It's not the rulers and clocks that are wrong. It's what we think rulers and clocks are doing. Let me put it another way. Imagine the universe as a racetrack. Every object has a speed and you expect the numbers to stack up neatly, but light doesn't play that game. Light behaves as if the racetrack itself stretches and squeezes so that no matter who's running, no matter how fast, light always crosses the finish line at exactly the same time. Not approximately. Exactly. Now, you might say, all right, maybe light is special. And that sounds reasonable for about 10 seconds. But the universe doesn't like special rules. If one thing forces a rule, everything else has to obey it too. That's the real danger. Once light refuses to budge, time and space are dragged into the argument whether they like it or not. Here's the mind twister. The speed of light isn't really about light. It's about how fast cause and effect can happen. It's the universe's way of saying, this is as fast as information can move. Faster than that, and events stop making sense. You'd have effects showing up before causes. You'd answer a question before it was asked. You'd knock over a glass and then watch yourself deciding whether to knock it over. Reality would become a bad mystery novel. So the universe draws a line. Not because it's tired, not because it ran out of energy, but because beyond that line, the idea of before and after starts to melt. And here's the part that really gets me every time. We didn't design this limit. We stumbled into it by accident. People were just trying to understand electricity and magnets. Wires, sparks, compass needles twitching on tables, and out of that mess popped a number, a speed, one that didn't depend on who measured it or how fast they were moving, a speed that behaved more like a law of logic than a property of light. At that point, physics had a choice: either throw away centuries of thinking about motion or accept that time itself is flexible. Most people don't appreciate how radical that is. We talk about time slowing down like it's a neat trick, like stretching a rubber band. But what's really happening is far stranger. The universe is constantly adjusting the flow of time and the shape of space to protect this one number, as if that number is more sacred than our intuition. And that leads to a dangerous question. If there's a maximum speed, what happens when you chase it? You don't crash into a wall. You don't hit resistance. Instead, the rules of measurement start to misbehave. Lengths shrink. Clocks tick differently, not because anything is broken, but because that's the only way the universe can stay consistent without tearing itself apart, which means the speed of light isn't a speed limit in the way a speed limit sign is. It's not telling you how fast you're allowed to go. It's telling you how reality is stitched together. And once you realize that, you can't unsee it. Every moment, every distance, every now you experience is quietly arranged so this limit is never violated. The universe bends time before it lets information cheat. Now, if that doesn't make you uneasy, it should, because it suggests that space and time are not the solid stage we imagined. They're more like negotiators, constantly compromising so that cause and effect stay in the right order. And once you start asking why the universe cares so deeply about that, well, that's where things really begin to get strange. Would you like me to keep going into what happens when you try to build a clock out of light itself? Good. Because once you build a clock out of light, you've essentially trapped the universe in a confession. Picture the simplest clock you can imagine. Not gears, not springs, none of that mechanical fuss. Just two mirrors facing each other with a pulse of light bouncing back and forth between them. Every time the light hits a mirror, that's a tick. Elegant, clean, nothing to break. And best of all, it uses the one thing the universe seems most obsessed with, light moving at its sacred speed. Now, if this clock is sitting calmly on your desk, the light just goes straight up and down between the mirrors. Tick, tock, tick, tock. Everything is peaceful. But now let's do something harmless, or so it seems. Put the clock on a train. The train moves smoothly, no bumps, no drama. To the person riding with the clock, nothing changes. The light still goes straight up and down, tick, tock. Same rhythm as before, but to someone standing on the platform watching the train go by, the story is completely different. From the platform, that light isn't moving straight up and down anymore. It's tracing a zigzag path. While the light is going up between the mirrors, the train is sliding forward, so the light has to travel a longer, diagonal distance just to keep up. Same on the way back down, longer path. Same speed, and here's the trap. Light's speed can't change. We already agreed on that. So if the distance the light travels is longer, but its speed is the same, then something must give, and the only thing left to give is time. The clock on the moving train ticks more slowly than the clock on the platform. Not because it's broken, not because motion affects machinery, but because the geometry of reality demands it. If time didn't stretch, the light would have to speed up. And that, apparently, is forbidden. What I love about this is how brutally simple it is. No philosophy, no metaphysics. Just mirrors, light, and a refusal by nature to let light cheat. Time dilation isn't an opinion. It's an accounting requirement. Now, people hear this and immediately say, but that's just how it looks. As if time itself is politely pretending to slow down for observers who aren't paying attention. But no, this isn't about appearances. It's about agreement. If both observers measure the speed of light and get the same answer, then their measurements of time cannot agree. There is no option where everyone is happy, and the universe chooses light over your intuition, every time. Now let's push this a little further because it gets better. Suppose instead of a clock, you're carrying a ruler, a nice solid ruler. You're zooming past me at some outrageous speed, close to light speed. I measure the length of your ruler as you go by. You measure it too. Surely we should agree, right? A ruler is a ruler. But again, light gets involved. To measure length, I have to decide where the front and back of the ruler are at the same time. That phrase, at the same time, is doing a lot of work. Because what counts as the same time depends on how light reaches me from the front and the back. And because light speed is fixed, different states of motion disagree about simultaneity. So your ruler, moving fast relative to me, comes out shorter, not visually distorted, actually shorter, in my measurements, while to you holding it, nothing is wrong at all, which is absurd, until you realize the alternative would be worse. If lengths didn't contract, then once again, light would be forced to change speed to keep measurements consistent, and that's simply not allowed. Space squeezes, time stretches, all to protect this one number. At this point, it starts to feel less like light has a speed limit, and more like space-time itself has a stiffness to it. Push too hard in one direction, speed, and it flexes in the others. And here's a delightful irony. The faster you go, the less space you have in the direction you're going, and the less time you have to experience it. It's as if the universe is gently discouraging you from ever reaching that ultimate speed by making the journey increasingly meaningless. Now, let's try a thought experiment that sounds innocent, but is actually lethal to common sense. Imagine you're chasing a beam of light. You're going fast, ridiculously fast. So fast that, by ordinary reasoning, you should be almost keeping up with it. Maybe the light looks nearly frozen, like a wave hovering in space. But that can't happen. If you ever saw a frozen light wave, you'd be measuring light at rest, zero speed, and that would shatter everything. Maxwell's equations, the rules governing electricity and magnetism, would fall apart. The whole structure of physics would collapse like a badly built card house. So the universe forbids that scenario entirely. No matter how fast you go, light never slows down relative to you. Instead, your time slows down, your distances contract. Reality rearranges itself so that you never catch up, which leads to a very strange realization. Motion through space and motion through time are not independent things. They're more like two components of a single budget. Spend more on one and you get less of the other. You can almost think of everything as moving through space-time at a fixed speed. If you're standing still in space, you're moving entirely through time. As you start moving through space faster and faster, some of that motion gets redirected away from time. Your clock ticks slower because part of your motion has been reassigned. That idea sounds poetic, but it's brutally precise. It's not metaphor, it's geometry. Now, at this stage, people often say, fine, light is special, space-time is weird, but surely this is just about observers and measurements. Surely nothing real is happening. And that's where experiments step in and ruin everyone's comfort. Particles created in the upper atmosphere, unstable, things that decay quickly, should never reach the ground. Their lifetimes are too short. And yet they do. Why? Because from our perspective, their internal clocks are running slow. From their perspective, the distance to the ground is shorter. Both descriptions are correct, and both are required to keep light honest. GPS satellites, same story. Their clocks tick differently from clocks on Earth. If we didn't correct for that, correct for the bending of time itself, your navigation system would drift by kilometers in a single day. This isn't abstract. This is your phone knowing where you are, because space-time refuses to let light misbehave. And now we arrive at a subtle but devastating point. If the speed of light is the same for everyone, then there is no universal now. No single slice of time that the entire universe agrees on. Events that are simultaneous for you are not simultaneous for someone moving relative to you. That means the universe does not evolve moment by moment in a single shared present. What you call now is stitched together differently for different observers. The limit on speed isn't just about how fast things move. It's about how reality orders events. And once you accept that, you start to suspect something even deeper is going on. The speed of light isn't a limit imposed within space-time. It's a clue about what space-time is, because limits usually signal structure. You don't get a maximum speed unless the arena itself has rules, angles, and constraints. Something like a geometry, something like a four-dimensional fabric where time and space are inseparable, and light traces out the boundary of what can influence what. And when you finally see it that way, the question shifts. It's no longer, why can't we go faster than light? It becomes, what kind of universe needs such a limit just to remain coherent? And that question pulls us out of clocks and rulers and into something far more unsettling, because now we're talking about causality itself, and whether the universe could even exist without this restriction holding everything together. All right, now we're standing right at the edge, where intuition gives up and something deeper takes over. Because once you realize the speed of light is really a speed limit on cause and effect, you're forced to confront a terrifying possibility. What if that limit didn't exist? Imagine, just for a moment, that signals could travel faster than light, not infinitely fast, just a little bit faster, enough to cheat, enough to cut corners. At first it sounds harmless. Faster communication, better technology, no waiting for messages. But the universe is not fooled by just a little. Here's the problem. The moment you allow faster than light signals, you can construct a situation where an effect happens before its cause. and not in a philosophical hand-waving way, in a precise, calculable, engineerable way. You send a message, someone else, moving relative to you, receives it before you sent it. Then they reply, and that reply reaches you yesterday. Now you're stuck in a logical trap. You receive a message telling you not to send the original message, so you don't send it. But then, why did you receive the reply? The universe hates this kind of loop. It's not that it's morally opposed to paradox. It's that paradox makes prediction impossible. And without prediction, physics dies. No laws, no explanations, no science, just chaos pretending to be reality. So the speed of light isn't an arbitrary number. It's the minimum requirement for logical consistency. It's the fence that keeps cause in front of effect. Light draws what physicists call a cone, a boundary separating what can affect an event from what cannot. Inside that cone, influence is allowed. Outside it, influence is forbidden. That structure isn't optional. Without it, the universe wouldn't just be weird, it would be incoherent. And here's the part that still makes me grin. Light doesn't just move through space-time. It defines space-time. If you strip away matter, strip away forces, strip away everything but the bare skeleton of reality, what you're left with is a set of relationships. Which events can influence which other events? And those relationships are completely determined by the speed of light. Distance isn't primary. Time isn't primary. Causality is. That's why the speed of light shows up everywhere, even where there's no light at all. Gravity waves propagate at that speed. Changes in electric fields propagate at that speed. Even the structure of empty space respects it. It's not really the speed of light, it's the speed of reality updating itself. Now let's tackle another stubborn intuition. People ask, why does it take infinite energy to reach the speed of light? As if that's the reason you can't get there. But that's backwards. It's not that infinite energy prevents you from reaching light speed. It's that light speed is unreachable by definition for anything with mass. The equations aren't putting up a wall. They're revealing a boundary between two categories of existence. Massive things. Things that experience time live on one side of that boundary. Massless things, like photons, live on the edge. They don't experience time at all, from a photon's perspective. If such a phrase even makes sense, no time passes between emission and absorption. The journey across the universe takes zero duration, not almost zero, zero, which means asking what it's like to move at light speed is like asking what it's like to be everywhere. Along your path at once, the question dissolves. And that's why you can't accelerate into that state. You'd have to gradually experience less and less time until time disappears entirely. That's not a speed, it's a different mode of being. So when people dream about engines powerful enough to break the light barrier, they're imagining the wrong obstacle. There's no barrier to smash through, there's a conceptual cliff. On one side, time flows, on the edge, time vanishes. There is no road connecting the two. This also explains something deeply unsettling. The faster you move, the more the universe rearranges itself to keep you away from that edge. Energy doesn't go into speed the way you expect. It goes into making time resist you. You pour energy into a particle, and instead of racing faster through space, it digs its heels into time. Its inertia increases. Not because it's getting heavier, in a classical sense, but because it's becoming harder to redirect its motion through space-time. Mass, energy, time, they're all tangled together. Pull on one, and the others shift. Now step back and notice what's happened. We started with a simple observation about light not adding velocities the way it should, and we've ended up with a universe where space and time are flexible, causality is geometric, and existence itself is divided by whether or not time passes. That's a long fall for a flashlight experiment. And it leads to a sobering realization: the speed of light is not the fastest speed allowed. It's the fastest speed that makes sense. Anything faster wouldn't just be hard to achieve. It wouldn't fit into a universe where events can be ordered, explained, or remembered. Which brings us to the strangest part of all. If the speed of light defines the structure of reality, then our everyday experience of time, this steady march from past to future, is not fundamental, it's local, it's conditional. It depends on how we're moving, where we are, and what paths through space-time we take. The universe doesn't give us a master clock. It gives us rules. And from those rules, time emerges differently for everyone. And that means when you say now, you're not pointing to a universal moment. You're pointing to a personal slice through a much larger, stranger structure, one where past, present, and future coexist in a way that defies every instinct you've ever trusted. Once you see that, the speed of light stops feeling like a limit and starts feeling like a signature, a sign left by the universe, quietly telling us how deep the rabbit hole goes. And if you're willing to follow that sign just a little further, you end up facing the biggest question of all, whether time itself is something that flows or something that simply is. All right, let's finish the journey slowly, because rushing would be ironic here. Once you reach this point, you start to feel a quiet discomfort that has nothing to do with equations anymore. It's the realization that time, the thing you trusted most, isn't doing what you thought it was doing. We talk about time as if it flows, like a river, like something moving past us. But notice something strange. You've never observed time flowing. You've observed clocks changing. You've observed memories accumulating. You've observed entropy increasing. But time itself, that's an inference, a story we tell to connect events. And relativity quietly suggests a different story. If there is no universal now, if different observers carve reality into different slices of past, present, and future, then the idea of a single, moving present starts to look suspicious. It starts to look optional from the space-time point of view, the view forced on us by the speed of light. Events don't come into existence one by one. They simply are, laid out in a four-dimensional structure. Your birth, this moment, your last breath, different locations in space-time, not beads sliding on a string. That thought bothers people deeply, and I understand why. It sounds like fate, like everything is frozen, like free will has been quietly escorted out the back door. But that discomfort comes from smuggling our everyday intuition into a universe that doesn't promise to respect it. You still experience decisions. You still remember the past and not the future. You still feel time moving forward. Relativity doesn't deny that experience. It explains why it's local, why it belongs to creatures like us, moving slowly, bound together by chemistry and warmth, living far from the speed of light. The flow of time may not be a property of the universe as a whole, but it is a property of being human. And that's not a downgrade, that's a clue. The speed of light tells us that reality is not built around human intuition. It's built around consistency, around causality, around the ability for events to make sense without contradiction. And within that structure, creatures like us emerge, creatures who experience time, who remember, who anticipate, who ask questions like this in the first place. Here's the twist I find most beautiful. The universe could have been built differently. It could have allowed instantaneous signals. It could have allowed absolute time. It could have let causes and effects blur together. But if it had done that, it might not have been a universe where complex structures, atoms, stars, brains, could persist long enough to wonder about their own existence. The speed of light isn't just a limit, it's a stabilizer. It's what allows the universe to be predictable without being boring, flexible without collapsing into nonsense, strange without becoming incoherent. And notice the irony. The same limit that prevents us from ever outrunning light is what makes meaning possible at all, because meaning requires order, and order requires that causes come before effects. Even your thoughts depend on it. Every idea you have is a cascade of signals, limited in speed, propagating through neurons, obeying the same cosmic rule that keeps distant galaxies from interfering with your breakfast. The speed of light is written into your thinking, whether you like it or not. So when people ask, will we ever break the light speed limit? I think they're asking the wrong question. The better question is, why does the universe care so much about preserving this limit? And the answer seems to be that without it, there would be no reliable before and after, no stable histories, no memories, no stories, no science, no you. The universe doesn't stop you from going faster than light out of cruelty or lack of imagination. It stops you because beyond that point, the idea of a coherent experience stops making sense. Light speed is not the edge of technology, it's the edge of intelligibility. And maybe that's the deepest lesson hiding inside all this mathematics and geometry. The universe is not required to be intuitive, but it is required to be self-consistent. And once you accept that, you stop being angry at its limits and start being amazed by its design. Because here we are, tiny, slow-moving creatures, able to uncover a rule that governs the entire cosmos, just by noticing that a flashlight refuses to behave the way it should. That refusal wasn't a flaw, it was a message, a quiet one, telling us that space and time are not what they seem, that reality is stitched together by deeper rules than motion alone, and that the speed of light is not a wall we crash into, but a signature left behind by a universe that wants to make sense. And the astonishing part? It worked.